Okay, so I know there's a lot of writing to begin with, but this just is going to be the conditional probability is what we're going to introduce today. So you can kind of see the goals we're going to calculate and interpret. We're going to talk about general multiplication and then tree diagrams, all right? So conditional probability is the probability that one event happens given that another event is already known to have happened. So what it looks like is this. It says the probability of A given the probability of B. So I wrote it out here, the probability of A given the probability of B. So the way it's calculated is that we find the probability of A and B, and then our denominator is, instead of being the whole total, is just going to be the probability of B, okay? And then, yes, you can flip the order, so you can have the probability of B given A, and it looks something like that, okay? So we're going to pause it as I write out the all right, so this is going to be our example. We did a two-way table. We have homeowners and not a homeowner. We're looking at people that have graduated high school, and then we also have people who did not graduate high school. Our total is 500, and so what we're going to do, let's just start off with the probability of a high school graduate given that they own a home, okay? And the way I have to calculate this is my fraction bar, okay? So this is going to be my numerator, this is my denominator. So I go to own a home, so that's a homeowner, and I go all the way to the total, okay? So the total is going to be my denominator, okay? Then I come back in that same place and I look till I hit the high school graduate or whatever my numerator is. So I'm going to put 221 and then grab my calculating device. And 221 divided by 340 is 65%. Okay. Nope, this is saying that you already own a home. So this event has happened. So we've owned a home, and now we're saying how many of them graduated high school for this data set. Okay. Yep. So if we switch the order though, so if we do own a home and they graduated high school, so now again, there's my fraction, high school. So I come down to high school, my total's 310. Go back up to home ownership, which is 221. So 221 divided by 310. Let's just round that to 72. It's looking better. It's looking good. That's all you got to do. And then work 4 part-time jobs. Jack in the Box, Burger King, McDonald's, and you're covered. Okay, so this is going to be another example of that conditional probability, but instead of being the total numbers like we have here, okay, what we can do is we can actually just already calculate the percent, okay? So what we would do is we'd say this one's 51, this is 38, this is 89, this is 0.09, this is 0.02, 0.11, 0.60, and 1.0. Sorry, so this is comparing having a cell phone and also having a landline, okay? This particular data set, unfortunately, did not give us the total number. So we're just kind of based it all off of the percents that they showed us, okay? But the cool thing about our conditional probability is it still works even with the percents. So we could say, what's the probability of having a cell phone given that they already have a landline. Okay, so then there's my fraction again. So I go back to the landline all the way to the end, find the total, and then I'm going to go back to the cell phone, and what is that? 0.51 divided by 0.60, 0.85, or that's an 85%. Okay. I think there's a homework question that has the decimals in there. I want to make sure you saw that. But we can remember they'll sometimes do this to us, and they'll just switch the order. And the lazy people will just say, "Oh, it's 85%," but then we got to go back to here, make sure, and actually calculate it. Don't times. That's 57. So make sure that you calculate it and you just don't, if it looks like they're the same, or should be different. There is a possibility it can be the same, but it's more likely going to be different. Okay. All right, so what we have here is, I'm going to pause it again and write it out. We're going to talk about our general multiplication rule. And what that looks like is the probability of A and B is equal to the probability of A times by the probability of B given A. Okay, so I'm going to pause it so I can write out the definition. Okay, so here is the long example, and everybody had to suffer as I wrote it out. Excuse me. Shannon hits the snooze bar on her alarm clock 60% of school days. If she doesn't hit the snooze, there's a 90% probability that she makes it to class on time. However, if she hits the snooze bar, there's only a 70% chance that she makes it to class on time. On a randomly chosen day, what's the probability that Shannon is late for class? All right, so what we're going to do is we're going to use a tree diagram to demonstrate what is happening, okay? Okay, so what's the first event? Snooze. Okay. So we've got, she hits the snooze. And then the other one is no snooze. Okay. Oops, let's get you up there. All right. So what's her probability of hitting the snooze? Nope. 60%. Okay, good. So we're going to put that as a decimal like that. Okay. So anytime we draw these arrows, even if we have like 3 or 4 or even 5, it always has to add up to, okay. So that means that this is 0.4. Excellent. Okay, so after she's hit the snooze, what's the two events we have? Okay, so we've got on time or late. And that happens both to these two events here. Okay? Okay, so how often is she on time if she hits the snooze? Okay, 70%. And this one is 30, right? Waiting. Correct. If she hits the snooze bar, there's only a 70% chance that she makes it to class on time. Okay? And if we go up here, she doesn't hit the snooze, there's a 90% probability that she makes it to class on time. So on time and not on time. All right. All right. So what we're looking at is we're going to take and just kind of follow the arrows. All right. So I'm going to go 0.6 times by 0.7. What is that? 0.42. Okay. And then I have, oops, let's come down here. I have 0.60 and 0.30 is 0.18. Then I followed this arrow. I got 0.4 and then 0.9. Then I followed this. I got two numbers after the decimal. So I got 0.4. Let's do it like this. 0.4 times by 0.1. So that understand that that's to be 4. How many numbers after the decimal do I have? So I got to put a 0 there so I have two numbers after the decimal. Okay. Okay. So what does this 0.42 represent? Well, it represents she's hit the snooze and she's on time. Okay. And what does this 0.18 represent? Well, she's hit the snooze, but she's still late. Okay. And then the 0.36 is she's not hit the snooze and she's on time. Okay. And then hits the snooze or no snooze is late only about 4% of the time. Okay. So the question was on a randomly chosen day, what's the probability that Shannon is late for class? Okay. So this is what we're worried about is when is she going to be late? Okay. So we're going to take our 0.18 and add it to the 0.04 for a 22% chance that she will be late for class. Okay. There you go. And then the other thing I want to remind you, guess what all these n totals add up to? Yep. And then that is our new material. And I'll pause it here so I can upload it and then answer questions from your guys' homework. Yes, sir. Yes. Should I put that up there now? A little bit. Not much. I'll give you extra credit. How about that? Yeah. The homework list. That one, this one's not. I just came up with this one today. Yeah. Yeah. Give me a second.